Bismillahirrahmanirrahim. Welcome to lecture number 8 of data science. We will discuss the topic data frame, data structure in today's lecture. This is the discussion agenda. We will discuss the data frame, data structure, and we will discuss how to query a data frame and how to index a data frame. So let's go to our Jupyter notebook. So this is our topic, the data frame, data structure. So data frame is actually part of the PD. If you remember that we have created the series data structure like by passing it a dictionary like name Chris, item purchase dog food, cost this one. This is one dictionary and we pass it to this one series to make it one series, let's say purchase 1. We create a second purchase, so we create pd.series, name Kevin, item purchase kitty litter, and cost 2.50. We create a third purchase as a series, pd.series, name, item purchase, and cost. Now we can create the data frame as, so this is df means PD means pandas, and for the series we use S letter, for the data frame we use df. So pd.data frame, and then there is a list, purchase 1, purchase 2, purchase 3, and let's say we have index store 1, store 2, store 1 and store 2. So the first two purchases are made in store 1 and the third purchase is made in store number 2. We can print the top few records and then it will print like, oh, you see this printing is very formatted compared to this one. It was simple tags, but here the data is formatted as rows and columns. So we have our name, item purchase, and cost as column name, item purchase, and cost. And then we have the indices, so store 1, store 1, store 2. So the data is organized as rows and column compared to the series data structure where data is only per row, but now we have rows and columns. So in the columns we are using these column names, the keys of the dictionary, and the rows are basically the indices. So this is how data frame works. We can query the data frame by let's say we want to print store 2, so it will print only one row, this one. So df.log, and you see it's an object, so it's not like this, but it's a different one. We can know the type df.close, and you see it's a one series. So this one row is a series, but as a whole it's a data frame. So data frame is basically a collection of series. Now we can do df.log store 1 and it gives us 2 records, store 1, store 1, and this is because there are 2 purchases in store 1. We can often, when we process data, we are interested in certain columns, like we are not interested in all the rows because typically we have maybe hundreds of columns, and maybe we are interested in just few columns. So let's say we want to search for row store 1 and we are interested in the cost column. So this is how we write. It takes 2 parameters. Remember, log is not a function, therefore there are no parentheses. It's an attribute, and this is index. So let's try to execute this one. So it gives us store1 and the cost. You can print store2 and cost. Since there is only one store2, so it's not printed, but since there are two store1, so therefore it is printed. We can change this rows and columns by printing df.transpose. So you see the store names, they become the column names, and the column names become the row names. Now if we print the cost, so it will print the cost of all the store. So df.t transpose.log cost, and you see there are all the costs: store1, store1, store2. We can print df.cost, and since it is changed, so then it prints this same record. But there is a difference. This one is object and this one is float. So what we can do store1 cost. This is another way of accessing cost per row. So the same as the previous command, this one, but this is just a second way, like df.log store1, and once you have that row, you extract the column. We can have the name and the cost, so everything, so all the rows for the column name and cost. So let's say like this, for everything, name and cost. We can drop certain rows. For example, if I say df.drop store1, so it will drop store1 and only store2 data is left. But it is because I have not assigned it to df, so the original df is not changed. So make sure that you use the copy function. It's the same as we discussed for series and arrays. So if you do df.copy, it creates a copy of df, and then I can say copy df.drop store1, and if I print copy df, it's like this. You see there is only store2, and this command is basically, it tells you drops specified labels from rows or columns, and it's actually basically the definition of the drop function. So copy df is basically changed because we are assigning this value. We can delete a column, so delete copy df name and copy df, so you see the name is removed. We can do df location by adding a new column name. So let's say location is none and df. So you see the copy, because of the copy function df.copy, the original df is not changed, but a copy is created and we perform some operation, and here when we perform this operation on the original df, the data is not changed. So you see a new column is added, location, and the data is none. We can change this data, so we can assign this loading. This is what we discuss in next, indexing and loading. So we can change the values of these locations. Now let's try to study data frame indexing and loading. So let's say we have cost and it print cost. So you see the row's name and column cost. If I perform the addition operator, cost plus equal to, so all the items are updated by 2. So you see it's 22, it's updated as 24. This is 2.4, 4.5, this is 5, this is 7. So vectorization, this is what we discussed last time. Vectorization is performed on all the data types or all the rows of the record. Now if you print df, it has updated values. The cost is updated. If you compare the original one, this is the cost, and if you see the updated one, this is the cost. Now let's try to load data. So we have let me open the directory. So this is what we see directory. This is our Olympics data. Where is Olympics? Yes, here. I just want to show you this data so you understand how this data is loaded in the Jupyter Notebook. So this is our CSV data. There are some 149 rows, and this is basically the total. And this is some data. This is the column numbers, but this is our initial column, and it's, I think, country names and some other attributes. I don't know what these mean, but some summer 01, 02, 03 total, winter 01, 02, 03 total, and games 01, 02, 03, and combined total. So this is the data, and this is what we want to load in our Jupyter Notebook. So let's see. Okay, so Kate, you know, Jupyter Notebook has IPython as a kernel, so we can perform the Linux operation in Python. So this is, you see, our top row 01, the same as here, and this is the column names, and these are the country names and some other data. So all the data is printed as comma separated values. Now I can read this data, olympics.csv, as a data frame. So what I do, pd.read csv, olympics.csv, and I assign it to df, and I print the top few values of df. So it is printed as this one. Now you see this one is none because this has no value. These are the column names, and these are the country names, and the top 4 records. Basically this is one record. Let me clean this one because this one is unnecessarily added. So let's try to clean it, and let's try to load it again. So you see unnamed, and these are the column names, these are the country names, and in addition to that, a new column as index is added. You can see there are no indexing of rows, but here we see indexing of rows. We can make index as the country names, uh, so we can do pd.3csv Olympics, index column equal to 0, and skip rows was the top row that we remove it. I think it will not affect anything. Yeah, so let's remove these skip rows. So here I deleted this data from the Excel sheet, but let's say I keep it as like this. So what I can do, if I don't remove it, so you see this is a bit messy, I can do by removing the top row is like this. So quite often we are not allowed to change anything in the Excel sheet, but what we can do, once we load the data in the Python, we can perform certain operation to clean the data. So you see the indices are gone, the numbers that Python has or Pandas has created are gone, and now our indices are basically country names. I can print df.columns, and you see these are the column names, and its type is object, and we can perform certain operation. So for column in df.columns, if column is 0 1, you see there is 0 1 and then space and then there is pictorial sign. So if it is 0 1, what we do, we replace it with gold and in place equal to true. It means change the column name. Similarly, 02 is changed to silver and 03 is changed to bronze, because these 01, 02, 03 are not comprehensible names, so that's why we change it to gold, silver and bronze. And there is something very strange character here. You see this character, so what we can do, we can change this character into hash to indicate this is a number. So you see, hash summer, hash winter, and the 01, 02, 03 are gone, and now we have gold, silver and bronze. So this is how we can perform indexing and loading data. Now let's try to study how to query a data frame. So df gold greater than 0. So all the record that has gold greater than 0, you see this Afghanistan, this is 0, so it will not be printed. So Afghanistan is false, and these countries are true, and some false and some true, because it's a Boolean structure. We can assign this df.where, where df.gold is greater than 0, so assign it to only gold, and we can print this nicely formatted data. So where there are greater than 0, it's a Boolean value, so it becomes not a number, and the others are just record. We can count the gold, only gold, gold.count. It will count the number of golds, We can do df.gold.count. So df.gold.count, I think there were 147, because the only gold in the df. So here we change it the gold greater than 0, so that is only gold. But there are the original one, there were 147. So something is wrong here. This is not a number, some missing values. So we can drop that by calling this function only gold dot drop, not a number, and it's a function, and we can print this only gold dot head. So you see that not a number is gone because these were Boolean values and they were not considered as numbers. Now if we do this one, df gold greater than 0 to only gold, and then we print it, and then we perform this operation, I think this one. Is 100, and if we perform this one operation, so what's the difference? The difference is that this one is clean version. All the missing values that were not considered as number, because in machine learning algorithm it's important that you have numbers. If you have text, you have to convert those texts to numbers. So you want to drop the missing values, or you can replace missing values with some numbers. So let's say we have this one. I think this is what we discuss here. Let's execute this command here. You see, it's the same. We can count the gold because there are two. So one is gold, this is gold 1, this is gold 2. So length of df gold greater than 0 and gold dot 1 greater than 0, and we OR them together, it gives us 101. And if we AND this operation, if this is equal to 0, and so it means gold 1 and gold, these are greater than 0, and gold 1 greater than 0 but gold equal to 0. And let's see, so there is only one row that is making it different. So this is gold is 0 but gold 1 is greater than 0. So that was the reason that we were getting only gold and gold. So only gold we were getting 100, and all the gold we were getting 147. Okay, so we can index data frames. Let's say we print df.head and we say df country is equal to df.index, and then df.setIndex is gold. This record is set as index and we print df. So you see the gold data, it becomes as index. So this is index and this is assigned as this one. We can revert it by df.resetIndex. Now the index are 0, 1, 2, 3, 4, which is assigned here, and reset index, the gold stay as it is. Let's say we have another data, pd.readCSV census.csv, and we have df.head. So these are the indices and these are some different rows and columns. I don't know how many rows. So there are 500 columns and 5 rows are shown, but there are different. So this is, let's say, an attribute SUMLIB, and we want to see how many are unique, because you see this is 40 and 50, and we want to print unique values. So unique are basically, if you print all this record, there are maybe, let's check it, how many rows are there. This was census data. Now if you check the rows, so you see this is a big data. This is a large data. This is not only called big data but a large values of data. So we are here 12,000. I think I better do like this. So 3,194 rows, and all are this value sum. So SUMLIB unique, these are just 2, 40 and 50. Then we have region, division, state, country, and state name, city name, some different other attributes. I don't know what are the uses of these attributes, but you can do different. Like if you want to know region, unique, so then you can write here region. So 3, 4, 1, 2. Let's say we want to see those SUMLIB that are equal to 50. So these are all 50 and the top 5 rows are shown, and this gives you more information what you can do with it. Let's say we want to clean the data and we want to remove some columns, so we perform some operation. Let's say columns to keep. So this is what we provide, and df is equal to df columns to keep df.head, and it has this data only. The other data is still there in the spreadsheet in the data frame, but we clean the data and we extract only those data that we are interested into. Now we can use state name and city name as index, and we print it. So this is state name and city name. These are used as index. If you want to know the city, let's say Michigan, and I think this is state name, and then this is city name, and if we print it, so this is the data that we have.